So we want to make a Taylor series for this function, centered at 0. So I think it's the next section. We see that that's called the Maclaurin series. So maybe we should list some derivatives. And I'm going to think of this as x minus 1 to the negative second. So the first derivative would be the negative 2 comes down. That's x minus 1 to the negative third power. Second derivative is 6x minus 1 to the negative fourth power. Third derivative, hopefully that's all we need before we see a pattern. Negative 4 comes down. Okay, so let's start doing the Taylor expansion. For the first term, it's just f of 0. The second term, it's going to be f, the first derivative of f at 0 at our center times x minus our center to the first power. And then it's the second derivative at the center times x, I'm just going to skip the minus 0 part, to the second power. And then we get the third derivative. That's x to the third power. Okay, and now if we actually substitute these values, if we plug in 0, 0 minus 1 gives us negative 1, negative 1 squared gives us 1, 1 divided by 1, this is 1. Here, if you plug in 0 into the first derivative, yeah, okay, 0 minus 1 makes negative 1, negative 1 to the third is negative 1. Negative 2 times negative 1 makes a positive 1. This is x to the first power. And over here, the second derivative at 0, so I'm playing in 0 for x again. 0 minus 1 is negative 1. Negative 1 to the negative fourth is a positive 1. And a 1 times 6 makes 6. And then this is x squared. And then the third derivative, oh, sorry, I'm forgetting something. Whoa, this is all divided by 2 factorial. I did that on a previous video, I think, too. I don't know why, but yeah, this is all divided by 1 factorial, 2 factorial, 3 factorial. The factorial grows along with the power there. And then for this last, sorry, so I still have to make the correction here. But for this last one, third derivative, plug in 0. So that's 0 minus 1 is negative 1. Negative 1 to the fifth is negative 1. Negative 1 times negative 24 makes a positive 24. That's over 3 factorial times, what are we at, x to the third power. Okay, so if we list out these coefficients, what do we got going on? I think I messed up here. The first derivative, if I plug in 0, 0 minus 1 is negative 1. Negative 1 to the third is negative 1. Negative 1 times negative 2 makes a positive 2. And so 6 divided by 2 factorial, that's 6 divided by 2. And then 24 divided by 3 factorial, that's 4. And we've got a pattern. So we're able to determine a sequence to complete the series that we need here. So since they want us to start at n equals 0, want to pay attention to that. We need the first term to be a 1. So how about n plus 1? Because 0 plus 1 makes 1. And then to make all these x powers continue to increase, I'm going to use x to the n power. And I think that's it. Because if you plug in n equals 0, x to the 0 is 1. And then we got 1 times 1 makes 1. If you plug in n equals 1 for this term, x to the first power is just x. So we got that part. And then 1 plus 1 makes 2. We got that part. Okay. If you have this type of problem, and it didn't have it centered at 0, just note that this is going to be like x minus 1 if 1 was your center. That's the only real modification. Everything else should be the same.